which seems to happen. So, hello everyone. Nice to see that we have a group of people listening in. Today we will have Pablo Vela presenting us about how he uses Pixi and Rerun to make computer vision research accessible and reproducible. I won't talk about his presentation more than that because he can probably do that himself. But he's a user for a long time already, and we're really glad that he wanted to present today. So thank you, Pablo, already, and hopefully we'll learn some cool new stuff from your work. Please go ahead.
Sure. Yeah, absolutely. So yeah, I'm Pablo. I have been using Pixi and Rerun for quite a while now, and so I'm excited to do this presentation. So I guess let's just get started. And if anybody has any questions, feel free to interrupt me or just ask. But yeah. So I guess who am I? So I'm a computer vision engineer. I've been working at Immersed for something like 5-6 years now. So I've been working on all different kinds of problems. In particular, the thing that interests me the most is 3D reconstruction. You'll see that in a lot of the examples that I've been working on. It's just something that's so cool and interesting to me. And I just like building stuff. It's just like whenever I find something interesting, I want to do something with it. So here on the right are some of the examples of different demos that I've built out for research code that's been provided. So one of them being SAM2 in-depth anything, another one being deep patch visual odometry, and then the Duster paper. And so yeah. So whenever I go through these, a paper comes out, some research code gets dropped, something happens. I've kind of noticed a few different things with them, right? So first of all, usually they're not the easiest things to get set up. And then even if I do get, some setup working, it's not going to be exactly the same setup as, the original researchers that put out this code had. And then, okay, I've gotten set up. I have the same setup as the researchers. Then try to actually run this thing on, let's say, my own data rather than a piece of curated data that is provided by the researchers is really hard. And then oftentimes I can't even tell exactly what this algorithm is doing under the hood, right? Oftentimes they just provide a final output, and I don't really understand what happened. And lastly, it's really hard to build on top of a lot of this research. Most of the time, you just have to clone and fork your own version, right? Most of the time, researchers don't make it super easy to build on top of. So then the question is, okay, so why am I, going through and taking research papers and trying to build demos? And for me, a lot of it is just, it's a very easy way to learn. Oftentimes with this, it's not much of a spectator sport. The fastest and easiest way to learn something is just to grab the code and mess around with it and try to do something interesting with it. Another part of it too is I just kind of want to show others that like having the right tools can really make a pretty large difference as to how easy it is to share your project and for the other people to use it and understand what you're doing with it. And I guess last, it's just fun for me. This is just something that I'm really interested in and I find cool. So yeah. So I just wanted to give an example of this. So this was a paper that I read that I was really excited about. That was super cool from the NVIDIA team. And I made a tweet and a demo about it, but I wanted to just add some caveats and motivating examples, which is first, I'm not a researcher. I'm an engineer that likes, to look into this stuff, and I think it's really cool. The other one is I know how difficult research is and the incentives there. So I just, kind of wanted to give my own anecdotal experience of like what it's like to keep up with the research and use other folks' codes and understand, how this thing works. So I guess let's just look into it. So the first example for this particular paper is, trying to get it installed. And here's, a typical installation thing, which is you have to clone a repo, get the submodules, check out those submodules, download the model weights, and then do a bunch of other, complicated installation parts. In this one, you even have to go inside of the actual rasterize and change some values on this very specific thing. And so the long and short of it is it's pretty hard to get things installed often with research code, and that just blocks accessibility and usability for others. The other question too is, that people often ask, why not just use Docker for this? This is, production standard tool. And part of the issue that I find often is that even with Docker, things are not super reproducible because, let's say you have a Docker image of a specific piece of code. That Docker image doesn't affect your requirements.txt, right? Like these requirements.txt Python dependencies could all be unpinned, and you have no idea exactly what versions of them. So the researchers have to go and not only figure out the Docker file, but also make sure that all the requirements set up for this specific thing are all locked in and specific to the project when they were building it. And then lastly, Docker can sometimes be a bit of a pain in the butt with GPU, and it's kind of difficult to install. So Docker has its place, but oftentimes I don't think it's the right tool for the job when it comes to research code. So another one, where I was showing is, how difficult it can be to run the code after it's installed, right? So usually researchers will just provide a link to pre-processed data for a very specific set of data that they tested on. And oftentimes you want to see, okay, how does this thing generalize? How well does this thing do outside of the code that was just tested? And so in this example, they basically have a set of bash scripts that you have to go in and change which data and which specific ones. And if you want to get your own, data set in there, it's non-trivial. It's pretty much very difficult to get this thing working exactly how we would want. And I guess the last point here is running a demo, right? Oftentimes when you have a demo, folks will use Hugging Face Spaces and Gradio to kind of have an example. But I usually find that, if you wait a month or two, after a paper's come out or something has happened, these demos are usually broken in some way because, Space went to sleep, something happened, and then the demo tries to rebuild and something changed, right? A dependency changed, something happened, and then you end up with this runtime error where the original researcher, the person that made this demo, has to go in and constantly maintain to make sure that this demo is up to date and nothing is breaking. And part of that is just because usually the demo code and then the code that was originally used to do the research are two separate repos. And so that makes things a lot harder to maintain and make sure that everything is working the way that it should. So I guess the argument that I want to make is the right tools can fix a lot of these issues, right? And so these are kind of the four tools that I use whenever I'm trying to look at a piece of research code to understand what's happening and then kind of share it with others. So obviously Pixi is a large one of that. It has a bunch of functionality that basically ensures that you can easily run, install, and then reproduce whatever piece of code that you're using. Rerun is kind of the next part of that, which is when you're actually using your code, you want to be able to see what's happening. Right? You want to be able to visualize how an object is tracked over time, or how a point cloud is changing, or where the camera positions are, rather than just the final output of, let's say, a rendered video or something like that. So Rerun is extremely helpful in this whole process of like introspecting what's happening in your code in specific portions. The other one is Gradio and Hugging Face Spaces. So especially when you're trying to share your demo out with others, you want to make it as easy as possible to interface with said demo, right? The previous example showed of like, okay, you just have some bash script, and if somebody doesn't know exactly what is happening there, it just makes things a lot harder. So having a friendly UI that allows you to just drag in some photos or a video or change some values, I think it's extremely valuable. And then last is just hosting your demo. Hugging Face is awesome for that because they provide free infrastructure to allow you to host this thing up and use a GPU, since so much of computer vision research now depends on having these beefy hardware. So I guess I'm going to go through Rerun first and kind of show what that's about. So I think probably the best thing to do here is just actually go to the Rerun website, just because it does a much better job explaining what Rerun is and how it works. So if I go here, so Rerun is basically an SDK and a viewer that allows you to log and visualize your data over time. And maybe one of the cool examples is this one here that they have, and you can just go to rerun.io-viewer, and it shows you kind of different examples that can be done. So you can see, it's a pretty cool and compelling visualization of here. It looks like the new scenes data set, which is just a self-driving car data set. And the big interesting part is that it allows you to log many different entities over time, right? And so you can, kind of scrub back and forward and see how this data set, is showing different positions of the point clouds, or how different bounding boxes move over time. It lets you really dig into, for example, if I want to see this camera, it tells me, what the focal length is of this specific thing, or the actual image blob that was there, and the resolution, and all of these kind of things. So Rerun just makes it super easy to take very complex time series data and kind of log it and visualize what's happening over time, as your algorithm is running, or for your specific data set. So this is a great example of Rerun, and they also have some really easy examples of how logging is done, here on their website. So I would definitely recommend you go and look at their website and check them out, because they're awesome. So that's Rerun. Makes it super easy to log pretty, interesting and complex visualizations. Let me keep going with this. The next one is Gradio. So Gradio just makes it very easy to build a front end for whatever demo that you're building. The beautiful thing about Gradio and Rerun right now is that they have a custom component that allows you to use Rerun inside of a Gradio UI. So you can build a prompt similar to this, or something to drop your image, so that you can easily log whatever it is that you need your algorithm to work with. And I'll show this later too in some of the examples that I've built. But yeah, Gradio means you don't have to learn any JavaScript or HTML or CSS, right? If you just want to be everything in Python, Gradio lets you do it with Rerun. And then the last thing is Hugging Face Spaces. So Hugging Face basically provides this free infrastructure to host whatever demo or thing that you want to use using this zero cluster. And the idea is that they are basically giving you free GPUs for a specific amount of time. So generally, rather than assigning one GPU to one demo, there's a cluster that you basically request a GPU, as for a specific function that you're using, and then during a specific period of time, let's say 60 seconds, you are given access to this GPU to run your algorithm or visualization or whatever else. And so that allows them to host this free infrastructure and give access to compute to many different researchers or people just wanting to show a demo. There are a few sharp edges with this. It can be difficult to get it working exactly the way that you expect. So it only works with PyTorch, and it has some compatibility issues, but generally it's a really cool service, especially because if I remember, it's free, or maybe I think you have to pay like $9 a month for their pro tier or something like that. But it makes it super easy to build a demo, post it on Hugging Face Spaces, and then many different users can use it. And it scales to, let's say, I think the example is Black Forest Labs has like 15 people using this demo, and so they have 15 GPUs running on this specific thing. So Zero and Hugging Face Spaces is super cool for that. So I want to kind of show the fix to the motivating example. So I built basically the equivalent. I just forked over the Instasplat repo, and I use a Pixi manager to make installation a breeze, right? So instead of having this big, giant, long, complicated list of things that needed to get done in order to install the Instasplat example, all you have to do is clone the repo, cd into it, and then Pixi run app. And I think a perfect example of that is I can actually show you this running on my Mac now. So if I go to this, I git clone, an example repo. This isn't the Instasplat one. This is one that works on my Mac, but it's basically the same. And I do this with all of my examples, where it's just a single command to get this thing running. So I cd into this, and then I do Pixi run app. This will take a minute while it's downloading all of this. And it should be pretty fast on my side just because everything's already cached, and Pixi does that, which is awesome. They just build a cache, and so downloading this shouldn't take too long. But once it's downloaded, then it'll ask me to pick which environment to run it in, and it shouldn't take too long. Just give it a second here. And so there it goes, downloaded everything, configure my environment, everything's ready. Now I just hit enter. And here you can see it's saying not running at 0 because it has to know the difference between when it's running on Hugging Face spaces versus running on some local machine. But it should be running here in a second, and then it should pop up a URL for me to go look at the demo. Second. My guess is right now it's just trying to download something. Just see what happens. This is always a fun part of live demos, where things don't go exactly as you expect. But let me come back to this in a second, so just it doesn't keep taking too long. But anyways, as I was saying, Pixi fixed a lot of the issues before, where you had this complex installation process. So it has a task runner that allows you to just chain commands and make sure that everything installs the way that you expect it. It has a lock file so that you're sure that every single dependency that you have is the exact same dependency that the researchers had when they made their repo. And then it has a TOML file. In this case, it can be either a pixi.toml or a pyproject.toml, where you define all of your tasks, all of your dependencies, system requirements, so everything that you could possibly need to run this. So that makes installation super easy. The next one is actually running the code. And so the way that I think about this is that oftentimes I feel like folks just think about making their demo code and their research code as close to each other as possible in some ways, because you want people to actually be able to use the thing that you're doing research on. And so that's basically what I did here, where I took their code base, and then I basically made a demo that interfaces really strongly with the code that they provided. And the part where Rerun and Gradio really shine is that Rerun kind of scales depending on what you need, right? So Rerun lets you log things in such a way that this works while you're doing development and debugging and any of that stuff, right? But it also lets you, kind of integrate this into Gradio and generate, a cool looking demo like this, where you have a very specific layout that you have in mind for how, people should be using this this tool or this demo. And then for hosting it versus locally versus online, Pixi basically has this multi-environment functionality that lets you have specific dependencies depending on where you are or what feature set you want to use. And so that's something that I heavily use to allow me to not have two different code bases for, one for local installation versus one for up in Hugging Face spaces. So now let's go back to the demo. Hopefully now it's actually working. So yeah, so you can see here, there's this running on local URL. So I can just click on that. And the demo for this other one that I've built, which was Mini-Duster. And I can just, go to this multi-image and then upload, let's say I'll upload these two files of, these are just pictures I took of my guitars that I have here in my house. And then I can run this. And so this is running locally on my MacBook. And one of the cool things about Duster is that it works on Mac, Windows, or Linux. And so, just performing inference, and then because of this integration with Gradio and Rerun, you can have this really cool looking visualization of exactly what happened. And you can see, like, for example, what the depth values are for each one of these, and then what the point cloud actually looks like, and the viewpoint from each camera. So that's an example of this thing running locally. here's an example where I have this basically hosted on Hugging Face Spaces, right? And I use more images in this case because I have a GPU available to me. And so you can see this is what it looks like on Hugging Face Spaces. And I programmatically change these two. So you can see that here, there's 5 different images, but the images aren't showing up on the left side here. And so so things didn't get cluttered up. Whereas here, I can just set it to show the actual images that were used because there's only 2 of them. So it's not going to, blow up this interface. So that's some of the power that Rerun provides to allow you to log. Maybe another cool example is this other repo that I made for it's called Deep Patch Visual Odometry, and so it's a neural network that basically you input a video and some camera intrinsics, and then from this video it's able to generate the camera pose and point clouds of this. And I hosted this demo also on Hugging Face Spaces, and so this one does require a GPU. So the cool thing about Rerun is that it allows you to visualize stuff incrementally. So for example, here, this is just a video I took of a pool where I walked around. Let's see. Right now it's using actually the same mini duster in the backend to estimate the camera intrinsics because I didn't have those. So you can see that it's just this video of me walking around this pool, and then you can see it's generating the the camera poses over time. And it lets you, kind of navigate forward and backwards in this as it's running to see how this thing is evolving over time. So, Rerun makes that super easy to do. And then I guess one last example is this instance flat one, which again builds on top of this duster paper. So one thing that I've seen with time is building on top of previous works, right? So duster makes it super easy to get kind of camera poses and point clouds. And in this case, you use that to initialize a splat, basically. And then you can see, for example, how the images are optimized over time, where they start like this fuzzy thing from the point clouds, and then over time they become much closer to the real image. You can see that too here in the kind of the loss plot. And the final output is this crisp looking Gaussian splat that looks much better than the original, kind of messy looking point cloud that you can see there. So those are just some of the examples that I had for different demos and pieces of research code that I've made, and to try and make it as easy for others to use. Importantly, both in a hosted environment like Hugging Face, and also locally, where all you have to do is go down, clone the repo, and then pixi run app, and boom, everything should just be set up, running, and ready to go. So there's a few things that I want to point out too is as you saw, I build on top of this duster people quite a lot, and I think something like what the prefix team is working on, which is pixi build, to be able to easily build on top of this. Because right now the way that I'm doing this, I just build a PyPy wheel file and basically call on that, and it's not the best, but it works for now. So I'm really excited about pixi build, and I think that could make it even easier to kind of share and build on top of demos. Something else that I'm kind of looking at is kind of avoiding the entire git cloning and then pixi run. I have a suspicion that there's probably an easy way to, kind of build a binary out of this whole thing and just easily just share this packaged app to somebody, and they can try it out immediately from their computer. So that's something that I would love to figure out. And then the last thing is kind of start moving things over to, the Conda Forge environment, or, just more of the Conda environment, where I can just, make something with pixi and then build it into a package that can easily be shared through, Conda. So that's it. That's my whole presentation. Let me know if you have any questions about anything. But yeah, that's it. Thanks, everybody.
Thank you so much, Pablo. That was an amazing presentation. I want to clap, but that's always a bit weird online. But there's tools in Discord to do that. Yeah, thank you so much. Some of the stuff you showed is really why we're making Pixi, and that's really cool. Also, Pixi build is something that we're very excited about for you to test out and try along. Are there any questions for Pablo? or remarks.
I have a question. What is like when you come it's like kind of twofold. Like, do you implement the papers? Is the code available, or do you like implement the papers yourself? And like, what is the biggest hurdles that you come across when doing so?
Right. So generally, the code that I use are already provided by the paper author. So let's say, for the instance flat paper, they release this open source code, and oftentimes it's not super easy to kind of go and dig through their code. So usually what I do is I will figure out inputs and outputs, right? So I'll try to just get something running that the author provides. So that's goal number one. Just get something running and see what this pipeline kind of looks like through time. Oftentimes I'll use something that's helped me like tremendously is actually type annotations. So I'll just go through and basically type annotate every single important variable that I need as I'm going through this stack. And then use something like bear type and Jax typing to basically make sure that it's actually the thing that I'm saying, right? So it's a bear type is just like a runtime type checker that will basically validate each variable and like function headers and outputs. And so that's usually my process is just get something running, type annotate everything so that I know what's happening, and then take that code and try to, massage it into a demo similar to that what you saw with the previous ones that I've seen. But yeah, that can take some time trying to figure out exactly what's happening in this research paper. So I'll have to kind of look at the code, look at the research paper, try and like put things together in my head, and then just step through what's happening there. And then this is a part two where Rerun helps. So this is where I meant that the demo code and the development code is really helpful, because then, for example, I'll log some image file or some point cloud file. There's something as it's happening, so I know how it's changing over time or how it changes as the algorithm is running through. But yeah, that's part of the fun of it. But yeah, it can be a time-consuming process.
Thanks for explaining that. Are there any more questions? So, if there are no questions from the team, Julian seems to have one.
I have another one if there's no question. Julian first, or we can't hear you.
Yeah, I think you're muted.
Can't hear you. Okay, yeah. My question is like you had like some things that were cross-platform. Is like the biggest cross-platform hurdle CUDA, or is it something else?
It's definitely CUDA. Almost always it's CUDA. So for example, for that instance flat example, that requires this differentiable rasterizer from the team at INRA, and this is something that only works for NVIDIA GPUs. So that's CUDA is definitely a big hurdle, especially in the machine learning and computer vision research. I think there's some papers, for example, the Mini-DPVO one, where they implemented it like fully in PyTorch, and so that made it easy to port across Windows, Mac, and Linux. But oftentimes there's, especially with research papers where they have some custom kernel or some specific thing that is CUDA only, it makes it harder to kind of do this thing.
Thanks, Julian. You want to try again?
Test. Yes. So one thing that people using pixi with machine learning struggle a lot is to get PyTorch running at all. Assuming you went through the hurdle one time, but how is it if you move to the next demo? Like, is it as hard again? Like, do you have to always get to work to get PyTorch and these PyTorch extension packages to work again?
Right. So this was an issue earlier on where, I would have PyTorch working in this specific pixi toml, and then I'd go to the next one, and then something will have changed or something will have happened where it no longer works for me. Yeah, I think I made an issue for like fixing the specific version of pixi, because that's the one thing that I've noticed, which is there's no way to like specify which version of pixi this project was built on, right? Because you can imagine, I spent a bunch of time. You guys are shipping so quickly, but like I spent a bunch of time and I was using pixi 0.2. whatever, and now we have 0.34, and so some things can kind of break there. One thing that has helped me a lot is I have a template where I have just made sure that this template definitely works with PyTorch. And so I can just, use this template and then afterwards go and have everything working. It's definitely gotten a lot easier than it was before. There was some problems before with like mapping between the versions of Torch in PyPy and Conda, and some other hiccups. But generally, it's a lot easier now. I can usually get PyTorch running pretty quickly. The other issue that I kind of find is CUDA. There's this weirdness where sometimes I avoid setting a system requirement for CUDA, but I download CUDA from the Conda ecosystem because it lets me choose which specific versions of CUDA. But some things will work and then other things won't work. And I have some confusion there. So like if I'm setting the dependency of, CUDA, why do I need the system requirement if that CUDA is being downloaded? But there's just some, little nuances there that make things a little harder for me. But overall, it's definitely made things a lot easier.
Thanks, Pablo.
If those were the questions, I would really like to thank you again for this awesome presentation. It will be online, so people can check it out after the fact, and they can ask questions in those chats or come back to our channel. And yeah, hopefully we can talk about it later again, and maybe you can share some more of your work. That would be awesome. Thank you.
Yeah, thank you.
Absolutely.
Super interesting.
Thanks, all. Appreciate it. Thanks, y'all.